Jai Hind everyone. I, Suvarna Mujumdar, Assistant Professor in Electronics and Communication Department, welcome you on a lecture on analysis and design of combinational circuit. First, we will going to discuss about the combinational circuit, and then we will follow how to analyze a combinational circuit, and when we have any problem statement, we have to design a combinational circuit. So, combinational circuit is nothing but an interconnection of logic gates, or we can say a group of logic gates either using universal gates, that is NAND gate implementation, or using NOR gate implementation. We have a logic diagram or logic circuit. The combinational circuit is defined as a circuit whose present output, depends only on the present input. There is no feedback mechanism in a combinational circuit. So, for example, if there are n number of outputs, we will have these outputs depends only on the present input combination. So, if there are n inputs, then m outputs is depending on present n inputs. So, there are different combinational circuits available like multiplexer, decoder, adder, subtractor, multiplier, magnitude comparator, and many more. When we have to design any circuit, combinational circuit, a statement or a problem statement is given to us. From that problem statement, we have to identify number of inputs, output, then we have to find the relation, and we have to proceed to design a logic diagram or logic circuit for that particular problem statement. First, we are going to analyze a circuit. So, if a circuit is given to us, that this is our circuit, this is the analog circuit, combinational circuit which is given to us, where F1 and F2, these are the two outputs, and there are four inputs A, B, C, D. So, from this circuit, we analyze this circuit by knowing how this F1 and F2 is connected with A, B, C, D. So, first we have to derive the expression. So, the statement is given that we have to derive the expression for T1 till T4. T1, T2, T3, T4, these are the intermediate states. Like T1 is the outcome of AND gate, T2 is the outcome of another AND gate, like this. So, final outputs are F1 and F2. So, we have to find the expression for these F1, F2 in terms of the four inputs, that is A, B, C, D. Then, while analyzing any circuit, we have to draw the truth table as per the input combination. So, in our case, for this example, we have four variables as an input. So, we have total 16 combination. Number of input variables, 2 raised to power the number of input variables will give us the combination. So, here we have 4 inputs. So, we have total 16 combination. So, we have to find the output, or we can say F1, F2, even T1 to T4 for these 16 outcomes. Then second step is while we draw the truth table, the third step is if we found that the expression for output, that is F1 and F2 is large, or we can say if we have to minimize the circuit, then in that case we can again resolve it by solving a K-map and find a simplified Boolean expression for the output. So, we are going to solve this example step by step. So, first we will write the expression for T1. So, here we will find that T1 is nothing but it is B dash inverted version ending with C. Then if we write for T2, it is A dash and B. For T3, it is A and T1. So, A ORing with T1. T4 is T2 XORing with D. So, now final F1 and F2, these are the two outputs expression. So, F1 is nothing but T3 ORing with T4 and F2 is T2 ORing with D dash. So we write the expression for these four outcomes and we will draw the truth table. So for truth table we have 16 combination for each ABCD and we will have T1, T2, T3, T4, the intermediate outputs, and then we will have F1 and F2. Okay, so here we will have 16 combination from 0, 0, 0, 0 to 4 times 1. Nine, 10, 11, it will be 12, 1, 1, 0, 0, 12, 13, 14 and last one is 15. So when we substitute here for T1 we find that it is the ANDing operation of B dash and C. So whenever these two combination will be 1, we have T as 1. So here for these two combination T1 will be 0. For this combination we will have T1. For this also, in this case it will be 0, again 0. This will become again 0, 0. 1, 1, 0, 0, 0, 0. So we have 4 input combination for which we have T1 as 1. Then in same way we will go for T2. So for T2, A should be 0 and B should be 1. So this will be the combination for which T2 is 1. For this combination T2, 3 and this one 4. For rest of the combination, our output T2 will be 0 as it is ANDing of A dash and B. Now in case of T3, if A is 1 then also T3 will be 1 and if T1 is 1 then also. So for this combination, last one T3 will be 1. And for these combination also T3 will be 1. Rest of the combination T3 will be 0 as T1 is 0 and A is also 0. Now for T4, it is XORing of T2 and D. So if either of these two will be 1, then T4 is 1. If both are 1 or both are 0, the T4 is 0. So for this combination, T2 and D is 0, so T4 is 0. T4 is 1, D is 1, so T4 1. T2, it is for D and T2, so it's 0, again 1. T2 and 0, so 1. These two, for this combination, D is 1 and T2 is 1. So it will be 0. 0, 1, 0, 1, 0, 1, 0 and 1. So like this we will find T1, T2, T3, T4. Now if we have to find F1 and F2, in the question it is given that we have to write this F1 and F2 in terms of the 4 input combination. So here we will place our value A ORing with B dash, C ORing with T2, XORing with D. So here T2 is A dash. So I will substitute the value of A dash here. So it's A dash B. Similarly, if we write here, it will be A dash B ORing with D dash. So we will write the expression in term of F1 in terms of input combination. Now we have to write the F1 and F2 value. So F1 is depending on T3 and T4, and if in either of the one is high, F1 is output is high. Similarly, for F2, D should be 0 and T2 should be high, either of these, or both are high, then also it's okay. So D is 0 and T2 is 0, so it's 1. D is 1, it's 0, 0, 0, again 0, that's 1. Sorry, this will be 1. As T2 is 0, it will be 1. So T2 is 0, it will be D is 0, so it will be 1. For this case, it is 0 and here again 0, so we will have 0, 1, 1. Here it is 1. Now here 1. So it will be, this is 1, T2 is 1, so it will become 1. Again 1, 1, 1, 0, 1, 0, 1, 0, 1, and last one is 0. So in this way, we analyze our this circuit, the given combinational circuit, and in this case, the F1 and F2 are the two outputs corresponding to ABCD inputs. So if any circuit is given to us, we have to analyze the circuit by writing the expression for final output in terms of input combination, and also we have to draw this truth table. Now, if we want to minimize this circuit, then we have to solve the K-map and reduce the expression. Now, we are going for the design procedure. So, in case if we have to design any combinational circuit, first of all, we have to find or determine the number of inputs and outputs, and we have to assign a symbol to each of the input and output. Then, we have to drive the truth table corresponding to the number of inputs and outputs, and we have to make a depending on the problem statement given, we have to find the output for each input combination. Then we have to solve a K-map for each output in terms of the input variable, and then as per the expression obtained from the K-map simplified form, we have to draw the logic diagram either using universal gate or using basic gates and or not. So for this design processor, I am taking an example of that we have to design a 4-bit 2's complementer circuit. And it is a combinational circuit. So in this case, we have to use 4-bit as an input, and we will have a 4-bit as an output for 2's complement. So first of all, we have to find the number of inputs. So here our number of inputs are 4, and we name it as A, B, C and D, and we have 4 outputs. So number of outputs 4, we name it as W, X, Y, Z. So 4 inputs, 4 output, 4 inputs. So we have 16 combination, and for each combination we have to find the respective 2's complemented value for outcome. So we will draw the truth table for this. So A, B, C, D, W, X, Y and Z. So again we have to write the whole combination for it. Four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and the last one 15. Now, as we all know, 2's complement, whenever we have to find a 2's complement of a number, we have to first complement that number and then we have to add 1 in this number. So, for example, in case of 0, 0, 0, its 2's complement, when we have to find, we have to complement it. This is the complemented version, and then we have to add 1 in it. So, when you add 1, it will be 0, here it is 1, so 0, 0, 0. So, same. We discard the carry. Now, for in case of 00001, we complement it and we add 1. So, it will become 1, 1, 1, 0, and we add 1, so it will become 1. In case of 0010, we complement it and then we add 1 to it, it will become when we add 1 to it, it will become 0, and here we get 1. For this case, we will have 1100, but we add 1 to it, so it will become 110. Here it will become 1, 0, 1 and 1. When we add 1 to it, this becomes 0, this becomes 0, and this becomes 1. In this way, we will find the 2's complement for each of the outcome. Now here if we add 0, 1 to here, so it will become 1, 0, 0, 0 and 1. Here it becomes 0, 111, and then we add 1, it becomes 0, 0, and this last will become 1. It becomes 0, 1, 1, 0, and it will become 1. So it becomes 0, 1, 0, 1. It becomes 0, and this will become 1. Zero, 1, 0, 0, 0, and 1. It becomes 0, 1, 0, 0. Now, when we find this, we have to solve the K-map for each of the combination. For 16 combination, we have to solve the K-map in terms of A, B, C, D. For example, if we have to solve for W, we find that it is 1, 2, 3, 4, 5, 6, 7, 8. Rest it is 0. So when you go for mapping or grouping, we will find it. We will have one quad, second quad, and third quad, and this will be a one cell. So it will be here it is A dash, B dash, A dash, B, AB, AB dash, C dash, D dash, C dash, D, CD, CD dash. So when you write for this, it will become A, B dash, C dash, D dash. Now when we write for this, it is A dash, B, and for this, it will become A dash D, And last one, this will become A dash C. When we solve this, we are having a value like A XOR with B plus C plus D. This will be the expression if we resolve this expression, and we will find in terms of XORing, if we have to find, it will be like this. Now, if we for W, X, Y, Z, if we resolve for all this, and we will have an expression for W, it will be A XOR with B, C, D. Like for W, then X, if we resolve it, it will be B XOR with C plus D. For Y, if you solve it, it will be C XOR with D. And for Z, it will be D itself. So these are the four expressions we obtained when we solve the 4 K-map, each in terms of A, B, C, D. Then we have to draw the logic diagram. So we will need 4 XOR gate. Z, D is something like this, Z. So it is D. Then we have an XORing of C and D, where we get Y. Then we have XORing of C, and we have ORing of D. We will have X. Then we have XORing of A. And ORing of B. In this way, we will have 2 OR gate, 3 XOR gate, and we will implement this 4-bit complementer circuit. So whenever a design problem is given to us, we have to first find the number of inputs and outputs. Then we have to solve, we have to draw the truth table, derive the output for each of the input combination, and then we have to solve the KMF for each output in terms of input, and then we have to draw the logic diagram as per the expression we obtained. So this is all about the designing and analysis of a combinational circuit. Thank you.